Okay, so today I'm going to discuss with spring related questions. What actually spring is? This is a spring, which is spring constant is K, and a block is attached with it. When we do displace it to the right, in that case, force is acting to the left, minus Kx. So force due to spring is directly proportional to negative of displacement. So force due to spring is equal to minus K times X. This K is known as spring constant. And it does depend on the material of the spring. As far as combination are concerned, and first thing is that I would like to tell all of you about its graph. If on horizontal axis we have taken X, and on vertical axis if we have taken K. So for your kind information, K is inversely proportional to X. So its graph will be a rectangular hyperbola. This is very important thing. Next, combinations of spring. And effective spring constant. One is spring series combination. So what happens in series combination is that this one is spring, which is spring constant is K2, and this one is spring, which is spring constant is K1. Springs are attached in such a fashion they appears one after the other. That's why this is called series combination. Always remember, for series combination, one upon K equivalent is equal to 1 upon K1 plus 1 upon K2 plus so on 1 upon Kn. This is very important facts which you have to bear in your mind for exam purpose. Now, next thing is parallel combination. So what happens in parallel combination is that in parallel combination, of spring. So what would be its arrangement? Its arrangement would be like this. Here it is spring constant K1, and here another spring which is spring constant is K2, and a block is attached with it. So for parallel combination, K equivalent is nothing but simply Ki, I run from 1 to n. This is equal to K1 plus K2 plus so on and so forth plus Kn. So this is for parallel combination. So this is just like capacitor. So what is the format for capacitor for parallel combination? C equivalent is equal to summation of C, and for series combination for the capacitor is 1 upon C equivalent is equal to 1 upon C1 plus 1 upon C2 plus 1. So one more design could be like this for parallel combination. This is K1. A block is attached with it, and this is K2. So this one and this one, same thing, and both are parallel combination. So firstly, you will have to trace out what combinations are there. As I had already told to all of you that spring constant and versus x graph is rectangular hyperbola. Why? Because k is inversely proportional to x. Second thing is, I'm going to discuss some more numericals over block. So this was the basic thing which you have to keep in mind in dealing with spring. Now suppose there is block M1, M2, M3, and it is placed over a smooth surface. Mu is equal to 0 and a force is exerted from left side, F. You might be asked to find out normal force exerted in between M1 and M2. So what are the normal forces? Suppose they are asking you what is the normal force is acting. Suppose this I mentioned N1 and this I mentioned N2. So the force which M2 will exert on M3 exactly is equal and opposite force will be exerted by M3 on M2. Same happens with M1 and M2. M1 apply force on M2 N1, so M2 will also apply force on M1 N1. Now, first and foremost, take it as a whole system. So this is system whose mass is M1 plus M2 plus M3, and it is being operated force F. So acceleration of the system will be F upon M1 plus M2 plus M3. Now, draw free body diagram of each one. So FVD of M1. So M1, what is happening with M1 is that F is being applied from left side and N1 is being applied from right side. And this is accelerating to the right with acceleration A. So equation will go, since it is accelerating to the right, so of course F will dominate. So F minus N1 is equal to M1 into A. This is equation number first. So FVD of M2. So what is happening with M2? N1 is being applied from left and N2 is applied from right, and it is accelerating with acceleration A. So equation will go N1 minus N2 is equal to M2 into A. This is equation number 2. And now FVD of M3. So what is happening with M3? This is M3. This is N2, and it is accelerating to the right. with A. So N2 is equal to M3 into A. This is equation number 3. What are your unknowns? Your unknowns are N1, N2, and A. So we have already find out A, N1, N2, and A. So since you have 3 equations, first, second, and third. So you can easily find out all these things. Now, next thing is, next type question. Because all these things could be understood through numerical. Now, pseudo force related question. Questions based on pseudo force. What is pseudo force? Suppose there is a lift. This is lift, and a block is placed in this lift whose mass is m, and this lift is accelerating upward with acceleration a with respect to an inertial frame. Now, question is that what forces are operating on this mass? So, of course, mg is operating downward, normally action is operating upward, and if we study it from an inertial frame which is at ground frame, then it will observe that this body is going upward along with the lift with an acceleration a. So dynamic equation in an inertial frame, top force minus bottom force is equal to m into a. So this is the first case. Now I am solving the same question through lift frame. So this frame is accelerating, that's why it is non-inertial frame. So for the non-inertial frame, when you are dealing question in non-inertial frame, then you have to bear in mind, apart from actual force, you have to exert one additional force, so-called pseudo force, whose direction is just opposite to the actual acceleration. So this will be the pseudo force, and this will be mass times acceleration. So this is m into a is pseudo force. Here, this is pseudo force. And in this frame, which is attached with the lift, this block appears at rest. So of course, the dynamic equation will be go top force is equal to bottom force. So N is equal to mg plus ma. This was built in non-inertial frame, and this was tilting. If we proceed this to, this will become N is equal to mg plus ma. So from here, what lesson I want to teach all of you is that regardless of the fact you are dealing a question either in inertial frame or non-inertial frame, force normal reaction will same. So regardless of the fact from which frame we are dealing, dynamics, final result will remain same. Final result, I am interested with force, will remain same. Now, I'm going to elaborate it in more detail. Suppose there is a lift and a block is placed inside it, and lift is going downward with acceleration a. So firstly, I am dealing it in an inertial frame. Inertial frame means ground frame. A frame, inertial frame, from telling inertial frame, I am talking about ground frame. So there is a frame which is attached with the earth. So it is an inertial frame. So any observer which is in an inertial frame will observe that this mass is also coming downward with the same acceleration as that of lift. So mg is operating downward, normal action is operating upward, and since this mass is accelerating downward, so equation will go mg minus n is equal to mass times acceleration. So n will become mg minus ma. Now I am dealing the same question through lift frame. This is lift frame. So this is lift frame, this is non-inertial frame. Why this is non-inertial frame? Because it is accelerating. So I have already told to all of you that when you are dealing with non-inertial frame, apart from actual force, you have to exert one more mysterious force, so-called pseudo force, whose direction is just opposite to the actual acceleration of the block. So its actual acceleration of the block is downward. So a force, pseudo force will act, and its value will be mass into acceleration of the frame. Since in this frame you are observing that this block is at rest, so what you will tell? You will tell that total upward force is total downward force. So you will tell n plus ma is equal to mg. So n is nothing but simply mg minus ma. So what are you observing is that, and it got verified and justified, that no matter from which frame you are dealing force, in all frame force remain the same. That's why it is said that force is an absolute concept. Next type question I'm going to discuss with all of you is that suppose there is a ceiling and a block, there is a ceiling and there is a pulley. Here it is a block whose mass is m1, and here it is a block whose mass is m2. This is fixed ceiling. Firstly, I will discuss about fixed ceiling. Gradually, I will discuss some complex situation. So firstly, you will have to understand that how many strings are there. So there are one string, and for your kind information, I would like to give you concept that in a given string, tension remains same, provided your pulley is ideal. So here pulley is ideal, and ideal pulley means mass of pulley is 0 as compared to block, and this is also ideal string. And in ideal string, mass of string is also taken 0 as compared to the mass of the connecting body. So when you take tension T, so tension will remain the same. And for your kind information, I just want to put forth that in the given string, tension remains same, and it is always directed away from the point of attachment. Here this is point of attachment, so it is directed downward. Here this is point of attachment, so it is directed upwards. Same will happen with here. So this is T, this is T. So when you will write FBD of M2, so what is happening with M2? M2G is operating downward, tension is operating upward. Now question is that which body will accelerate in which direction? It is completely arbitrary. You can assume any direction. Suppose you are assuming that you don't know that M1 is greater to M2 or M2 is greater to M1. So you just assume any direction. So for the time being, we have assumed acceleration vertically downward. Now question is that suppose someone assumed upward direction, then what would happen? So listen carefully. If you once you have assumed direction of acceleration, if in final result, if acceleration comes out positive, that means your assumption was perfect. If acceleration comes out negative, that means your assumptions are exactly opposite to the reality. Magnitude of acceleration is exactly same, but direction is just opposite to your assumption. So as we have assumed the acceleration of m2 vertically downward, so of course m2g will be dominating, that's why it is accelerating downward. So we will write m2g minus t is equal to m2 into a, and for this block m1. So what is fbd of m1? fbd of m1. So what is happening with m1? This is m1. No one could devour to operate gravitational force. m1g is operating vertically downward direction. In upward direction, tension is being operated. And as m2 is coming downward, so common sense suggests that m1 will go upward. So this will be the direction of a. So what would be its equation? So t minus m1g is equal to m1 into a. So this is equation first and this is equation second. So your t and a are unknown, and you have crafted two equations, this and this. You can easily find out